In the last lecture, I gave an assignment of 3 numerical problems, and I think it is necessary to solve these questions. You may have tried it at your level. One by one, I will attempt those questions. 2 questions are in continuation. I just extend this question, the second question, which is calculate the number of atoms, molecules in 4 grams of helium. I extend it for AMU of helium and 4 moles of helium. This will give us a comprehensive information about discussion on mole and mole concept. We know this is a gas, noble gas, inert gas, which exists in atomic state only. There is no helium molecule. Why no helium molecule? We will discuss it when we start the chapter chemical bonding. Why it is not He2, why it is He. So there is practically no difference between atoms and molecules of helium. But we will write helium is a monoatomic molecule. Maybe its atomic weight 4 AMU means 1 mole of helium 4 grams, and it is 6.02 into 10 raised to the power 23 helium atoms. It exists in atomic state. Now, coming to this step, atomic weight 4 AMU, what does it represent? It represents 1 helium atom. This is answer to our question, 4 AMU of helium. So number 1, 4 AMU of helium is 1 atom of it. Second part, 1 mole or 4 grams. 1 mole or 4 grams, 4 grams. 4 grams of helium have Avogadro's number of helium atoms. Second part, 4 grams of helium, it has 6.02 10 raised to the power 23 helium atoms. Last part, solution lies within this statement or relation. 1 mole of helium, Avogadro's number of atoms, 4 moles of helium, 4 into Avogadro's number of atoms. Third part, 1 mole of helium, it is 6.02 10 raised to the power 23 helium atoms, and 4 moles, 4 into Avogadro's number. So this is the solution of this question, which is all about helium. 3 different statements. Calculate the number of atoms, molecules in 4 grams of helium, 4 atomic mass units of helium, and 4 moles of helium. First clarification that I gave, there is no difference between helium atom and helium molecule because helium is a monoatomic molecule. It is a inert gas or noble gas. 4 AMU of helium, atomic mass of helium is 4. So 4 AMU of helium means 1 atom of it. 4 AMU is its atomic weight. So we write 1 mole of helium, 4 grams, and it has Avogadro's number of helium atoms. Now, another part, 4 grams of helium. This statement itself gives the solution. 4 grams of helium has Avogadro's number of atoms. Third part, 4 moles. 1 mole of helium has Avogadro's number of atoms. And 4 moles, 4 into Avogadro's number of helium atoms. So this was the solution of this problem, which I said or told you to solve at your place. Now, this question. A lead pencil dot weighs 0.01 milligram. How many atoms does it have? I explained the meaning of it all. Suppose it is lead pencil which we use with an eraser and mark it. This is dot. This statement says this lead pencil dot weighs 0.01 milligram. How many atoms does it have? So what is the element that is involved in this question? Lead pencil. It is not lead element. It is graphite, which is a crystalline form of carbon. So this is misleading. A lead pencil, just to divert your attention, a lead pencil which has the element graphite, that is carbon, a dot of it weighs 0.01 milligram. Now we shall attempt this question systematically. We shall attempt this question systematically. Lead pencil has graphite, matlab carbon as the element. Carbon atomic weight is 12 AMU. 1 mole of graphite, 12 grams, and it has 6.02 10 raised to the power 23 carbon atoms. Let us convert this weight into moles. Weight of carbon, it is 0.01 milligram, but must be converted into grams. Will be 0.01 into 10 raised to the power minus 3 gram. Matlab, divide it by 1000 and we get its conversion into grams. This is 10 raised to the power minus 2 into this, so it is 10 raised to the power minus 3 grams. Weight of carbon in this dot is 10 raised to the power minus 5 gram. Moles. 10 raised to the power minus 5 and divide it by its atomic weight. I may write the formula first. Number of moles of carbon, weight over atomic weight. 1 into 10 raised to the power minus 5 and divided by 12. 0.833 into 10 raised to the power minus 5. 0.0833 into this, or 8.33 into 10 raised to the power minus. We have shifted this decimal 2 places forward. So it will decrease by 2. It becomes 10 raised to the power minus 7. This is the number of moles. Question is solved. 1 mole of carbon has this number of atoms and these moles. Simple multiplication and we got here. 1 mole of carbon has 6.02 10 raised to the power 23 carbon atoms. 8.33 into 10 raised to the power minus 7, 6.02, 8.33, 10 raised to the power 23, 10 raised to the power minus 7. We shall multiply about 50 into 10 raised to the power 23 minus 7. This would be probably the number of carbon atoms. In these calculations, we are ignoring 0.02 and multiplying it directly. This was solution to this problem, problem number 2. Then there was a problem about sodium thiosulfate. Sodium thiosulfate. I want to leave that question to you. I told you about its molecular formula, structure of thiosulfate anion, and so on. So, okay, I leave it for you. But if there is any problem, you can directly contact me through WhatsApp, mobile number 9815990066. I leave that question to you. I leave it to your wisdom that you can do it, because that was quite elaborated last time. You can contact me for its solution on this WhatsApp number 9815990066. Of course, from this app you know my name, Professor Sarbjit Singh, Associate Professor, Khalsa College, Amritsar, retired. There is another aspect. We could have postponed this discussion till we have discussed Berzelius hypothesis, Avogadro's law, and so on. But just one assumption, no cramming at all, One assumption, we shall solve it in when we discuss Avogadro's law. And that is 1 mole of a gaseous substance, all gaseous substances, or vapors of a volatile liquid which is volatile, that is converted into vapors in no time. The easiest example is petrol. It evaporates very fast. Ethers are very fast to evaporate. About ethers we shall study in nomenclature of organic substances. Functional group ether, then different ethers, dimethyl ether, methyl ethyl ether, it is diethyl ether, very volatile. So this is particular for substances which are gaseous in physical state or are highly volatile liquids. And the statement is 1 mole of a gas or vapors of a volatile liquid occupies a volume of 22.4 liters or 22400 milliliters. Condition is at STP, standard temperature and pressure, or NTP, normal temperature and pressure. The conditions standard temperature, it is 0 degrees Celsius, or we shall study in the chapter on gaseous state 273 Kelvin. Pressure is 1 atmosphere or 76 centimeter or 760 millimeter. When a gas is maintained at 273 Kelvin and under a pressure of 1 atmosphere, it 1 mole of it will occupy 22.4 liters, or multiply by 1000, 22,400 milliliters. So again, a question related to mole. I wanted to discuss it during our discussion on Avogadro's law, but we can carry it down here because we have just in a momentum about solving the mole concept problems. Now, suppose we have carbon dioxide. Its molecular weight is 44 AMU. To mention that we are discussing gaseous carbon dioxide. Carbon dioxide is found in solid state also in the form of dry ice. Its molecular weight is this: 1 mole of carbon dioxide, 44 grams, 6.02 10 raised to the power 23 molecules, and another addition occupies a volume 22.4 liters at SDP. It occupies volume 22.4 liters at SDP. We can extend it further to find out what information is provided by moles in case of substances. One molecule has 1 carbon atom, 1 mole will have Avogadro's number of carbon atoms. One molecule has 2 oxygen atoms. 1 mole will have 2 into Avogadro's number of oxygen atoms. We may elaborate. 6.02 10 raised to the power 23 carbon atoms, also 2 into 6.02 10 raised to the power 23 oxygen atoms. So comprehensive information. We have come to know about everything so far as carbon dioxide is concerned. Its mole weighs 44 grams, has Avogadro's number of molecules, occupies a volume 22.4 liters at SDP, has Avogadro's number of carbon atoms, and has 2 into Avogadro's number of oxygen atom, and 3 into Avogadro's number of total atoms. Such questions are asked in competitive examinations, where we may be asked number of carbon atoms or oxygen atoms or total number of atoms contained in a given mass or given volume of carbon dioxide. Now, it was simple example of carbon dioxide. We may discuss another example before we take on the numerical problems. Say it is a methane, marsh gas. It is also called marsh gas. It is found in marshy places where humidity is high. Its molecular weight, it is 16 AMU. 1 mole of methane, 16 grams. Avogadro's number of methane molecules and occupies 22.4 liters at STP. It has Avogadro's number of carbon atoms and 4 into Avogadro's number of hydrogen atom. The last point, it has 5 into Avogadro's number of total atoms. We have 6.02 10 raised to the power 23 carbon atoms, 4 into 6.02 10 raised to the power 23 oxygen atoms, 5 into 6.02 10 raised to the power 23 total atoms. So this is the working of mole concept or miracles of mole concept. If you have any problem, frame your problems. Frame your problems. Always ask a question related to the topic. Question asking doesn't mean I give a statement and you say why. Why is not a question. Put a practical problem. Put a practical question. Asking why. This is no question. Supposing I explain a thing and say, ask questions, you say why it happens. Okay, I elaborated. Why has no end. You may ask again, now why this? No, why this? No. Frame a proper question. I say, this is the solution. You say, why this is not the solution. It will tell me that you have taken up the topic. You have grasped the subject. Know why. I say, this thing happens like this. And you will say why, you will ask why it doesn't happen like this. Another method. Or you refer to some other technique. So frame your questions. Know why, WHY. Know why. Ask your question. Frame your question. WhatsApp me. I will reply. I will answer your question. Now, let us attempt our numerical problem. Question is, calculate the number of hydrogen atoms in 1.5 gram of methane. This doesn't involve volume of methane. Let us first attempt this, then we will involve volume in it. Calculate the number of hydrogen atoms in 1.5 grams of, let us make ethane. It will ease our calculations. Ethane, molecular formula C2H6, molecular weight 12 into 2, 24 plus 1 into 6, this is 30 AMU. Weight of ethane 1.5 grams, they fair number of moles. Weight over molecular weight 1.5 over 30, it is 5 into 10 raised to the power minus 2 moles. 1 mole of ethane 30 grams, 6.02 10 raised to the power 23 ethane molecules, 22.4 liters at STP, and hydrogen atoms. We shall ignore the number of carbon atoms. 6 into Avogadro's number of hydrogen atoms. 6 into Avogadro's number of hydrogen atoms. The solution is crystal clear. 1 mole of ethane has this number of hydrogen atoms, and these moles will have how many number of hydrogen atoms? Question is finished. Every time it will take just one step to complete the calculations. 1 mole of ethane is equivalent to 6 into Avogadro's number of hydrogen atoms. So फिर 5 into 10 raised to the power minus 2 mole, 6, 6.02 into 5 into 10 raised to the power 23, and 10 raised to the power this. It is 1.8 into 10 raised to the power 23 hydrogen atoms. The solution is complete. Ignore this 0.02. 5 into 6, 30. 30 into 6, 180. So it is 180 into 10 raised to the power 23 minus 2, 21. 180 into 10 raised to the power 21. This is the answer. We put a dot here, 2 decimal places from right hand side, and it increases by 2, it becomes 23. So it is 1.80 into 10 raised to the power 23 hydrogen atoms. This question is finished. Let us attempt another question, volume based, which is volume based. Calculate the number of oxygen atoms in 1.12 liters of ozone at STP. Now this is volume based question. Ozone, O3, molecular weight 16 into 3, 48 AMU. 1 mole of ozone, how many grams? 48 grams. 6.02, 10 raised to the power 23 molecules. And how many oxygen atoms? 3 into Avogadro's number, oxygen atoms. We have this information on board. We have 2 methods of solving this question. We have 2 methods to solve this question. One is converting this volume into the number of moles. Let us do it. Volume of ozone is 1.12 liters. The fair A number of moles, volume of ozone over volume occupied by 1 mole, 22.4 liters. We have not mentioned here. So this is 22.4 liters at STP. This was also to be included. Volume of ozone is 1.12 liters divided by volume occupied by 1 mole, 22.4. It is 5 into 10 raised to the power minus 2. So, coming to the statement, once again, we are to calculate the number of oxygen atoms in 1.12 liters ozone, which comes out to be 5 into 10 raised to the power minus 2 moles. 1 mole of ozone has this number of oxygen atoms. and the number of oxygen atoms in this number of moles. 1 mole of ozone, 3 into 6.02 into 10 raised to the power 23 oxygen atoms. 1 mole of ozone, 5 into 10 raised to the power minus 2 mole, 3, 6.02, 5, 10 raised to the power 23, 10 raised to the power minus 2. This will give us 10 raised to the power 21. This will give us about 90, or if we are very particular, we will write like this. So rationalize 9.03 10 raised to the power 22 oxygen atoms. This is answer to this problem. You should not have any difficulty. If there is, you can ask for its explanation at this number. You may ask your questions through WhatsApp at this phone number. We can have another problem. Calculate the number of moles in 100 liters of the given gas. In 100 liters of the given gas. No information about the gas, but that statement is a splendid statement. It said 1 mole of any gas or vapors of a volatile liquid will occupy a volume of 22.4 liters, so maybe any gas. 22.4 liters of the gas means 1 mole, and 100 liters. Question is finished. It may be any gas. 22.4 liters of it are equivalent to or same as 1 mole. So, unitary method, 22.4 liters